In this video, I'm going to walk you through the process of reconstructing bones, specifically how we take fragmented or incomplete fossil data and turn it into a coherent, scientifically informed 3D structure. We'll start by examining the reference material. This could include CT scan data, fossil photographs, or anatomical comparisons. At this stage, the goal is not to jump straight into modeling, but to carefully understand the form, symmetry, and any unusual features that may exist within the specimen. Before reconstruction begins, I extract the bone structures from the CT scan data using 3D slicer. This step involves segmenting the fossil from the surrounding material, adjusting threshold values, refining masks, and isolating the regions that represent bone. It's a careful process because small mistakes here can affect the entire reconstruction later. Once the segmentation is clean, I generate a 3D model from the skin data to use as the base for further work. In this particular case, the specimen we're working with is highly unusual. Based on initial observations, there are indications of internal structures that could resemble organs, possibly even something like a heart or valve-like forms. The surface texture is also remarkably smooth, raising questions about potential soft tissue preservation. While this is extremely rare and still needs scientific validation, it makes this reconstruction especially interesting. One important thing to note: this specimen is extremely small and very fragile. Because of its size, the skeletal elements are highly fragmented, and many of the bones are incomplete or have suffered significant damage over time. This makes the reconstruction process much more challenging, as the available data is very limited and requires careful interpretation, especially with a specimen like this, where internal structures might play an important role in interpretation. At this stage, I also perform a subtle surface refinement using sculpting tools. This helps smooth out irregularities from the skin data while preserving the original structure. The goal here is not to alter the anatomy, but to make the forms clearer and easier to read for further reconstruction. Interestingly, this specimen also appears to be an egg fossil, based on its overall shape and the fact that it was found near previously discovered bird fossils. However, confirming this is not straightforward. In some cases, fossils like this preserve only a curled-up embryo, without any visible shell. If a shell was originally present, it may have been leathery or could have dissolved over time. In fact, only more evolutionarily advanced dinosaurs are known to have laid hard-shelled eggs. Here, you can begin to notice a structure that resembles a limb, possibly a small leg with 3 claw-like digits. While still tentative, features like this help guide the reconstruction process, reconstructed based on anatomical logic and comparative data, ensuring the final result remains as accurate as possible. Additionally, in the central region of the fossil, there appears to be a mass that could represent an internal organ, possibly the liver. However, this interpretation remains hypothetical and would require further scientific analysis to confirm. Next, we move into the initial reconstruction phase. Here, I begin by placing the available bone fragments into their approximate anatomical positions. Alignment is critical, especially with a specimen like this, where internal structures might play an important role in interpretation. Once the fragments are roughly in place, we refine the proportions. This often involves comparing with related species or known anatomical references. Because the preserved bones are limited, parts of the structure must be carefully interpreted and reconstructed based on anatomical logic and comparative data, ensuring the final result remains as accurate as possible. At this stage, I incorporate additional anatomical structures using 3D modeling in Blender to enhance the overall visualization. This step is intended to improve clarity and interpretability, allowing the reconstructed form to be more easily understood in a spatial and anatomical context. The additions are based on comparative anatomy and structural reasoning, ensuring that the resulting model remains as consistent and scientifically plausible as possible while still serving as a visual aid for analysis and presentation. In conclusion, this reconstruction represents a careful integration of available fossil data, digital extraction techniques, and informed anatomical interpretation. While certain aspects remain hypothetical due to the fragmentary nature of the specimen, every effort has been made to maintain scientific plausibility and transparency throughout the process.